All right, folks. We're going to be talking about section 2.2 today, and we are going to be looking at what's called conditional statements. And this is eventually going to lead into what's called a proof. Okay, now if you've heard anything from anyone talking about geometry, proofs are the hardest part that we'll study in geometry. And don't worry, we'll walk you through, we'll take baby steps, and you'll eventually get to the point where you can do a proof on your own. But to start things off, in order to build a logical argument, so this section, even this chapter, is not going to seem a whole lot like mathematics. It's going to be focused on logic, because a lot of times we think of mathematics having to do just with numbers, but it's so much more than that. And in fact, I can recall my buddy who went to Ohio Northern, and he had a lot of friends who were lawyers because they have a good law degree over at Northern, and their law professors would say, hey, if you're going to get an undergrad as opposed to get it in political science, which a lot of guys do, get it in mathematics, because you're able to think logically through a process from beginning to end. And so we're going to start that all right now. We're going to start that process of understanding how to think logically and use what's called a conditional statement. So I'm going to jump right into it, and we'll continue to kind of come back to what we just talked about there over the course of this chapter. But there's a lot of terms here in this section, and so I apologize about that. We'll try to keep them straight. Don't worry, we're going to come back for your next lesson and review everything, make sure we've got it down. Yeah, let's get into it, and I want you taking notes on this. I want you writing it down. I will be checking to see if you have the notes down. So here we go. Let's go ahead and take a look here. So the first thing I want to look at is this. I'm going to try to make that a little clearer. There you go. Okay. So I've written these terms down already, so you can feel free to go ahead and write them down, but I'll probably speak on certain things and make sure we have this down. So the first thing is, if I ever ask you to determine a truth value of a statement, I want to know if it's going to be true or false. Okay, and I'm going to teach you how to determine that when we get into conditionals and determine their truth values. But yes, a truth value is to whether a statement is true or false. The negation of a statement is to change the meaning of the statement to the opposite truth value. So for example, I wrote down here, we won the game, okay? Well, the opposite of that would be, we did not win the game, okay? And so what it really means when it says the negation is to make it the negative form of what you presently have, okay? So if I was to say, today we don't have a pep rally, the negation of that would be, well, a double negative. You wouldn't say, today we don't have a pep rally. You'd say, today we do have a pep rally, because two negatives make a positive, okay? So again, the negation of a statement is to change the truth value to the opposite meaning, opposite truth value, and you usually do that with the word not, okay? Conditional statement, this is really important, and we'll talk more about it here in a second, is an if-then statement. So when you think of conditional statements, guys, really conditional statements, they kind of rule your life. An example would be, if I choose to break curfew, then I know I'm going to get in trouble. If I choose not to set my alarm, then I know I'm not going to wake up on time, okay? If I choose to not go to practice, then I probably won't be playing that week, you know? Our conditionals, they really rule our lives, and so that's why we want to think about the truth value of these, because you don't want to be swayed by unproductive arguments, if that makes sense. So anyways, the next part, beyond a conditional statement, okay, I didn't put a conditional, I didn't put an example down there, but you can think of, I'd love to hear an example that you guys come up with, okay? If you like me, circle yes or no, okay? Back to when you were in probably grade school. Anyways, the hypothesis of the conditional is the if part, okay? If you think about the scientific method, what do you start with? You start with your hypothesis. So in an if-then statement, you have to start with the if being your hypothesis. The conclusion is the then. If this takes place, then this will take place. It happens after the if, and so we have the conclusion. the order doesn't have to be if then, okay? It could be something like this. You're going to be in trouble if you, okay, whatever it is. Well, that if whatever it is your hypothesis, and the conclusion is going to be you're going to be in trouble, okay? So just something to think about there. Lastly, for your notes here, is this the different ways or different types of conditional statements, okay? And what you're going to notice down here is a simple way of identifying this is your usually the if part, and this is your Q part. The first statement implies the second statement. I shouldn't say if part because it's going to change here in a little bit. But this is the first part of your statement and the last part of your statement. This arrow we oftentimes refer to as implies. So P implies Q is how we would read this. But a conditional, I wrote one out here. If I don't set the alarm, then I won't wake up on time. Okay? So that would be P implies Q. The P is the first part. It'd be the hypothesis in this case. And the Q would be the conclusion. Okay? Now, the converse, if we state the conditional backwards, you notice here that we switch these two. Sometimes that changes the meaning of our statement. Okay? In this case, it would be this. If I don't wake up on time, then I didn't set my alarm. Okay? Now, I would say, that's kind of a tough one whether it's true or false. I would say that's false because you may have set your alarm, but you hit that snooze several times, so you didn't wake up on time. Okay? So that would be the converse, is to switch these two. Again, if I didn't wake up on time, then I didn't set my alarm. Okay, so you can change these verbs, do. Anyways, I wasn't an English major, but you can change those slightly as long as it doesn't change the meaning of the statement there. Okay. Now the inverse is actually the negation of the conditional. So this little squiggle right here and this squiggle right here, it means the word not, to make it the negative. Okay, we talked about making a statement the negative. I can drive. The negative form would be I can't drive. The negative would have some form of not in it. Cannot drive. So what that would look like with respect to this original conditional would be this. If I do, okay, don't is negative, so I make that positive. If I do set the alarm, then I will wake up on time. Okay? So I just changed both of those, their meanings, as far as whether they are, in this case, they were a negative form already. I changed it to a positive. Okay? The contrapositive is the negative form of the converse. Okay? So that would be this. If I do wake up on time, then I did set the alarm. Okay? So again, you can change the tenses of these as long as you don't change the meaning of the statement. Okay? But I changed it, or you could say if I wake up on time. You don't even need that, I guess, anymore. If I wake up on time, then I set the alarm, because the negative form is no longer there. Okay? So we're going to get this down. You just need to know the overall view of that. And I'm going to walk you through just a couple more things when it comes to these conditional statements. Okay? So again, we're still working on our logic here. And so here's what I want you to see. We just talked about the negation. It's have not. Again, that's the symbol for not. You see it right there. The statements P and not P have opposite truth values. Okay? So opposite truth values. So this word conjunction and disjunction, I'm not concerned about that. What I am concerned about is you need to know that this caret means the word and in mathematics. Okay? And this V means the word or in mathematics. Okay? So if you have two statements and there's joined by an and, this is true only when both P and Q, both statements, are true. And I'll show you that down here. For example, here's the first example here. It says this. It's P and Q. Statement P is an elephant is a mammal. That's true. Q is a square has 4 right angles. And so if we have P and Q, I'm going to say an elephant is a mammal and a square has 4 right angles. Since both of these statements are true, if I link them with an and, they're also going to be true. So down here, here's a little chart that might help you out to figure this out. If the statements are both true, when we have a linked by an and, it has to be a true statement if both statements are true. Okay? Now from here, let's go over here. Well, I could go to an or. Let's go to an or. An elephant is a mammal, or a square has 4 right angles. Okay? Since both of these are true, when you have an or statement, it says it right here. If you have 2 statements linked by an or, if is true, if P is true, if Q is true, or if both are true. So as long as one of the statements is true, or both are true, you end up having a true statement right here. Okay, so if I look down at my chart, okay, if P is true, the first statement is true, the second statement is true, then the and has to also be true because both are true. Okay, the or also has to be true because, again, both are true. Okay, so let's say if one is false. Okay, if I was to say something like this, tomorrow is Saturday and the Buckeyes are playing. Okay, so tomorrow is Saturday is true. The Buckeyes are not playing because of COVID right now. Okay, so tomorrow is Saturday and the Buckeyes are playing. Is that a true statement? Well, and means both of them have to be true, so I'm going to say this is a false statement. Okay. Tomorrow is Saturday or the Buckeyes are playing. Well, or means one or the other has to be true, so I'm going to put true. Okay. We could continue on going on down, but the same thing's going to be true here. As long as one of these is false, linked by an and, it's going to be false. If one is true, linked by an or, one or the other has to be true. That is true. Okay. But if they are both false, then they are both false. Okay. So I hope that makes sense when you have an and or an or. So if you have those type of problems, make sure you can decipher what's happening there. Okay. All right. So taking a look at the first couple questions here, it says here, let's see, we're at 13 minutes. Use the following statements to write a compound statement for each conjunction or disjunction. Then find its truth value. Okay. So what I'm going to do first, well, P and Q. So 10 plus 8 equals 18. And Q, September, has 31 days. Okay, so I wrote that out. Now, in order for that to be true, both have to be true. Okay, so as I pull up my trusty calendar, September does not have 31 days. So because one of these is false, linked by an and, I'm going to put false. Okay? So I want you to go ahead and evaluate each of those other ones. Now remember, this last one here, that little squiggle, means to make it a negative form of whatever that is. Okay? So see if you can go ahead and answer those for me. Okay? Going down here, you see some good examples. I'd encourage you to read through these. These are the conditional, converse, inverse, and contrapositive. You've got all these examples here. Make sure you understand how to write these out. Okay? Oh, and the last statement, I forgot to mention this. Let's read this paragraph here about the biconditional. A conditional statement always has the same truth value as its contrapositive. So these two will always have the same truth value. Okay? If this is true, then this is true. Okay? It then says, and the converse and inverse always have the same truth value. So you're going to see this play out. Sometimes when we include the negative form, it can be confusing, so you can look back at the converse if you want to. It says, if you can make a compound statement from a conditional statement and its converse, you can write a single biconditional statement. A biconditional is written by linking the hypothesis and conclusion with the phrase if and only if. I'm going to make this a lot easier to understand. Okay? Here's what I'm going to say. You write a biconditional statement when the conditional, I'll write this down here. When the conditional and converse are both true. Okay? When they're both true, you can write the biconditional, and you can link the phrases with the words if and only if. So I'll get to that in a little bit. So the first section, you're going to do this for me here in a couple of minutes. Write each statement in if-then form. Okay? Now, what I usually do is when there's a pause, put a slash there. That's where the then goes. All apes love bananas. That's where the break is in the statement. So if it is an ape, or if you have an ape, then it loves bananas. Okay? You have to be careful not changing the statement here, but this still agrees with all apes love bananas. If it's an ape, then it loves bananas. Okay? Just turn it into an if-then statement, not super hard. Okay? And make sure it agrees with the statement there. Okay. Let's move on to, let me check one more example for you. Yeah, let's do this. Okay? I've got two more things we can do. This next section says this. Write the converse, inverse, and contrapositive of each true conditional statement. Determine whether each related conditional is true or false. If the statement is false, find a counterexample. If the conditional and its converse are true, write a biconditional. Okay? So here's what's happening. Remember the conditional is written like this. Okay? Here's the P, here's the Q. The converse is the opposite. Q implies P. Okay? So we're going to switch this. So let's start with this. If you live in San Diego, then you live in California. Okay? Well, there's only one San Diego in the world, so I'm going to say this is true. Okay? So if I switch it, if you live in California, then you live in San Diego. Is that true or false? Okay. Well, that would be false because you could live somewhere else. Okay. I'm going to misspell this. Let's see here. Sacramento would be an example of another place you could live. Okay. Now, the inverse is the negative form of the conditional. So if I go ahead and do this, okay. Now, if I go ahead and write this out, if, now the negative form of you live in San Diego would be if you don't live in San Diego. Then, in the negative form of you live in California, I would be then you don't live in California. The contrapositive would be the negative form of the converse. Oh, wait, let's go. If you don't live in San Diego, then you don't live in California. And I'm going to say that this is also false because, again, I could live in Sacramento or San Francisco or wherever else you want to list in California, okay? Just because I don't live in San Diego doesn't mean I can't live in California. For the contrapositive, it's a negative form of the converse. So if I say not Q, then not P, that would be this. If you don't live in California, then you don't live in San Diego. Okay? Now remember, there's only one San Diego. So if you don't live in California, then you don't live in San Diego. This is also a true statement. Okay? So remember, the conditional and the contrapositive and the converse and inverse have to have the same truth values. See that? And even we can use the same counter arguments. Okay? Same thing with these two. Okay? So the biconditional down here cannot be written. I'm going to put a little slash there. Okay? Because both the conditional and converse have to be true, or all four of these statements have to be true in order to write a biconditional. Okay? All right, last thing I wanted to cover with you was this. In order to write a biconditional, I can either convert the following statement into a biconditional. I can convert this into an if-then statement. Complementary angles are two angles that have a sum of 90. So I'm going to put my slash right there. Okay? If angles are complementary, then the two angles have a sum of 90 degrees. And guess what? That's true. They do have a sum of 90 degrees. Okay? The converse, so that would be the conditional. The converse is to flip that. If two angles have a sum of 90 degrees, then they are complementary. Okay? Two angles have a sum of 90, then they're complementary. Also true. Okay? So, since both of them are true, we can write the biconditional, the conditional its converse. The biconditional would look like this. Angles are complementary. Sorry, that got a little out of control there. Didn't know you were not seeing that, okay? Angles are complementary if and only if they have a sum of 90. Okay, if and only if they have a sum of 90. All right. So, I hope that makes sense to everybody. If it doesn't, we're going to continue to come back and revisit that topic of conditionals, converse, inverse, and contrapositive, how to identify whether they're true or false. And through all this, again, there's going to be lots of reviews, so don't worry. We'll get it down. So, anyways, have a great night. Good night.